using it, okay? When we're thinking about what is scientific notation, it is a way to write very large and very small numbers. That's what our video was talking about yesterday when we saw those different ones. All the different ways, the DNA, the big numbers, the small numbers. It's just a way to write very large and very small. This should have been small numbers, okay? When we write those very large numbers, the definition is that it's C times 10, and we're looking at the power. And this power is going to be positive if it's a really large number. Just like on our homework quiz, that was a positive exponent for the one that was a large number. And this exponent is actually negative if we are working with a small number. And a small number that we're talking about is just like a decimal number, not negative, but just a decimal, between 0 and 1. And it just gets really, really small. Okay? So as we use scientific notation, today you're going to be doing a little bit of a project thing with your partners. What I'd like you to do right now is tell me, how would you find each of these numbers? So if I'm looking, and let's just number them, let's put a number 1, a number 2, and a number 3. If I have 3 times 10 to the third power, is that in scientific notation? Yes, because it's the number between 1 and 10. The other two are not in scientific notation, but we still want to use those. So what would I have to do to write that number? I would write it out as what? Move the decimal over 3 places. How many would I move this decimal over?
4.
So a number 1, I'd move the decimal 3 places, and number 2, we're going to move it 4 places. So, and when we're moving in both number 1 and number 2, we would move the decimal which direction? To the right or to the left?
To the right.
We're going to move it to the right. And the first one, we would have moved it 3 places. The second one, and sometimes we use these like little bold things to just say, you know, it's the same as the line above. To the right, only thing this time it would have been 4 places. What number would we get? When you do both those, what would you end up with? Daisy?
3,000.
3,000. And how about if we do the last one? Would we still get 3,000?
Yep.
Yes. And that last one, number 3, that one, we're moving the decimal instead of to the right. Which way would we move it when it's a negative exponent? We move it to the left. And in this case, because it's a negative 1, we move it to the left 1 place, right? And it says, are all 3 of these equivalent? Are they all the same? Yeah. They're exactly the same. They all came out to equal 3,000. Now these two are not written in scientific notation, but they still, we know how to move the decimal point like that, okay? So the next part says, which of these is written in scientific notation? I would like you to circle the one, check with your shoulder partner and see if you guys agree. That is in scientific notation. Circle the one of those 3, and then check with your shoulder partner and see if you agree. This is the one I think, or equals 65. No, which one? Second one. So, which of these 3 is? This one is in scientific notation. Okay? It says explain. This one is not because what?
They're not between the 1 and 10.
Okay, the first number, and that first number that we're talking about is this 30,000, is not between 1 and 10. Now, if I'm looking at the last one, what's my reason there?
Because we would have to be, that's like a decimal. So
Right, point 3, again, it's not between 1 and 10, right? It would have to be 3 if it was going to be in scientific notation. Okay? So then it says, which one of these is greater. What I'd like you to do is right behind each number, I want you to write it in standard form for me. So do both of them in standard form.
What's standard form?
Standard form means like the decimal notation of how we usually write our numbers. So if I'm starting with this one, Elizabeth, and I have 8 times 10 to the negative 3. What am I looking at it in standard form? 0.008. If I'm looking at the next one, Adam, 4 times 10 to the negative 1. 0 point, right? So it says which one is greater. So which of these two expressions are greater? I would take a look at this. You can compare them and you can put the other zeros behind, right? You guys done decimal comparison probably in 6th, 7th, 7th grade. And we definitely know which one is greater. I'll have some people just put down the 0.4 is greater. But we really could say 0.4 is greater than 0.008. So on the test, which is not this week. Next week, we have to finish with lesson 11, 12, 13, 12 and 13 are kind of review. 11 is our last lesson. Then 12, 13 are review kind of lessons as we do. We don't really take any more notes. We will probably be looking at our test being towards the end of next week. It'll be the first grade that'll go on to your quarter 2 grade, okay? This week, we're gonna finish this up, this homework quiz, but so when we're looking at this on that test, I'm gonna ask you, and I may give you one of these in decimal notation on the test, written in a story proverb, and one like in scientific notation. And I'm gonna ask, which of these is greater? You're still just writing them both either in standard form or looking at it in scientific notation. And if you wanted to keep it in scientific notation, this negative exponent of negative 3 is telling us that we had to have the 0 with 2 zeros in front of it, whereas this one doesn't have any zeros before the 4. So this one is definitely much smaller. It then will ask you something like, well, how much greater is it? So if we're asking how much greater, what operation am I thinking of doing to find how much greater? Raise your hand. What am I thinking? How much greater is this than this? What do I have to do to find how much greater? Anyone having any idea if I'm looking at that? Dylan, what do you think? How much greater? I got these two things. I know the 0.4 is definitely bigger, and I want to find out how much bigger. How about if I say Adam has $2 and you have 10, and I want to find out how much more you have? What would you do? Subtract. So what do you think we want to do here? We want to subtract. So we are going to subtract. So how much greater? We're going to take our larger one, the 0.4, and we are subtracting the 0.008. Decimal subtraction, you guys did last year quite a bit of decimal operations. If we are subtracting that, we're gonna have 0.392.
So you know how if we do the decimal, let's say, can we not put the 0 out like before the like if it's 0.4, can we do that? Or does it have to be 0?
I'm usually gonna have you, I won't mark it wrong, but usually just for place value is a good idea, but I wouldn't mark it wrong. So that's it for notes today. We're doing a little more. Again, I want you to take a look at this. I'm actually one between the two of you have to keep your notes. One and two of you must keep your notes. Because after I talk about what the assignment is, this picture on your notes, this is what we're doing in class. So one of you in your notes. Just one of you. I don't want your workbooks out. I just want your notes. We have one note, and other people's stuff is going off their desk because you're not going to have time to do it in class. So one of you should have your notes open this page in your notes. Okay? Both of you don't have to have only one of you. Okay?